Module overview. The foot is a complex, load-bearing structure that plays a vital role in movement, balance, posture, and expressive grounding in figure drawing. Often neglected or oversimplified, the accurate and expressive rendering of the foot can elevate the realism, narrative, and anatomy of the full figure. Drawing the foot convincingly requires a deep understanding of its intricate anatomy, how it supports weight and locomotion, and how it contributes to gesture and composition in both static poses and action scenes. This module explores the skeletal framework, muscle groups, planes, and functional design of the human foot. You will learn how to simplify the foot's form through constructive anatomy techniques, represent it from various angles and perspectives, and convey ground contact, motion, and emotional weight through gestural and structural mastery. First, skeletal anatomy of the foot. The human foot is composed of 26 bones grouped into three main sections: A, hindfoot; rear foot; calcaneus, heel bone. The largest bone supports body weight and connects to the Achilles tendon talus, sits above the calcaneus and connects the leg to the foot, forms the ankle joint. B, midfoot, navicular, cuboid, and cuneiforms, three bones, form the arches of the foot. These bones are wedge-shaped, helping distribute weight and absorb shock. C, forefoot metatarsals, five bones, connect midfoot to toes. Phalanges, 14 bones. Toes, three for each toe except the big toe, which has two sesamoid bones embedded in tendons under the big toe to support flexion. D, arches of the foot: medial longitudinal arch, inside arch, lateral longitudinal arch, outside edge, transverse arch, across foot. These arches help with shock absorption, propulsion, and weight transfer. Second, major landmarks and surface anatomy. When drawing the foot, key surface landmarks guide the depiction of form and function. Ankle bones: medial and lateral malleolus heel, calcaneus. Large bulge in posterior view, top of the foot. Visible extensor tendons, ball of the foot, pad under metatarsal heads. Toes, taper in size, big toe often points inward. Arch area, hollow in medial side, cast shadows in weight-bearing stance. Third, muscles and tendons of the foot. While many movements are controlled by leg muscles, the foot also contains intrinsic muscles critical for fine movement and structure. A, extrinsic muscles originate from the leg. Gastrocnemius and soleus, calf muscles, control heel raise. Tibialis anterior, dorsiflexion, raises the foot. Fibularis muscles, eversion and stabilization. Flexor and extensor, digitorum, control toe flexion and extension. B, intrinsic muscles within the foot. Plantar muscles, control arch integrity and toe motion. Lumbricals and interossae, allow toe spreading and fine control. Flexor hallucis brevis, moves the big toe abductor hallucis, gives medial curve to inner arch. C, tendons and fascia, extensor tendons, visible on top of foot when flexed. Plantar fascia, thick connective tissue supporting the arch, often a focus in plantar fasciitis. Fourth, functional form and weight distribution. The foot is designed for shock absorption, propulsion, and stability. Its structure supports upright walking, bipedalism. In standing position, weight is split between heel and ball of foot. In walking, heel strike arrow arch, flex arrow toe off phase, toes grip the ground and help with balance, arch compresses and rebounds with each step. Understanding how pressure shifts during motion helps in realistic pose construction. Fifth, proportions and structural relationships. Foot is roughly the length of the forearm from elbow to wrist. Toes taper in size but are not perfectly straight. Big toe is larger and slightly angled inward. Arch sits medially, not in the center ball of the foot, and heel form main weight-bearing triangle. Sixth, simplification techniques for drawing. A, box plane method. Break foot into a wedge-like block for heel. Use a rectangular prism for midfoot. Divide toes into tapered boxes or cylinders. B, gesture and contour. Use rhythmic curves to connect heel arrow, arch arrow, ball arrow, toes. Establish weight-bearing side with stronger, grounded lines. Draw negative spaces between toes for accuracy. C, top-down and foreshortened views. Use ellipses to foreshorten toes and ball of foot. Be aware of toe splay and perspective compression. Seventh, drawing feet in context. Feet behave differently in various situations. Standing, both feet grounded, one often takes more weight. Walking, one foot flat, the other in transition. Running, heel often off the ground. Sitting, foot may be relaxed, collapsed arch, cross-legged or bent positions. Foreshortening, compression of arch includes shadow and ground contact to anchor the feet in space. Eighth, common mistakes in drawing feet. Flat soles with no arch, identical, evenly spaced toes, ignoring toe angles or overlaps, no differentiation in bone or tendon visibility, lack of proper weight distribution. Fixes: study from reference, photos, anatomy apps, casts, practice contour and gesture from life, use constructive forms, not outlines. 9. Rendering techniques. Use highlight and shadow to reveal planes of the ankle, toes, and arch. Render tendon definition on top of foot. On the bottom, pad the ball and heel with soft value shifts. Use cast shadows to suggest pressure and ground contact. Learning outcomes. By completing Module 10, you will Understand the anatomical structure and function of the foot construct and simplify the foot in dynamic and static poses. Represent foreshortened feet in perspective, capture gesture, balance, and grounding in full figure drawings. Avoid common mistakes and strengthen technical and expressive clarity.